Okay, so we're going to be doing lesson 1, 2 in our Algebra 1 books. We're going to go over order of operations and then evaluating expressions. Now, how many of you guys have heard about the order of operations? That's good. I'd like to see most of you guys' hands up. So when we talk about this, we're going to need to know a few vocabulary words first. The first we're going to talk about is power. Okay, remember, power is like an x squared. Right? And it's just a different type of operation. Just like multiplication, division, addition are all operations, so is a power. What does x squared mean? What does it mean to do? X to the second, but what there you go, x times x, right? So it means multiply by itself the 2 times, right? Or if it was to the third power, it'd be 3 times or 4 times. All right, so that's going to be power. We're going to be dealing with some exponents today. Next word is going to be simplify. And that means to make the math smaller, right? We're going to take a lot of math and try to make it smaller. And an example of that might be like if I have x plus 5 minus 2. Okay. Is there a way I could make that problem simpler? Yeah, we could do the math part with the numbers, right? The numbers over here. So what we could do is we could change this to say x plus 3, yeah. X plus 3, and that's simplifying. And you can obviously see how the one on the right's shorter, more simpler to look at than the one on the left. Right. Next word we're going to look at is evaluate. Now, the book, is pretty consistent about saying simplify and evaluate. But when we're talking, when we kind of say simplify and evaluate, we kind of almost mean the same thing. So evaluate is replacing a variable with a number and then simplifying. All right. So if I was going to evaluate, and let me get some more space. There we go. All right. And I'm going to take what we had up here, that x plus 3. And I want to evaluate when x is equal to 2. So to evaluate, I'm going to take out the x and replace it with a 2. So here, I'm going to put in a 2 instead of an x. Everything else stays the same, so I get 2 plus 3. We can simplify that to 5. Good. Now, I think we all kind of had an understanding of what these two words meant beforehand, but just to clarify the difference between the two. So we're looking at problem 1 on page 10. And we have part A and B. Part A is 10 to the 7th power, and B is 0.2 to the 5th power. Each one of these are powers. And let's start with the top one here, okay? What does it mean to be 10 to the 7th power? Yeah, that's what, 4, 5, 6, 7. Okay? Now, when you have to be careful because you don't want to put your brains on autopilot when you're doing your math and see 10 to the 7th and think that's 10 times 7. Right, I see it a lot of times when you start working too fast. You need to make sure that you're being careful about it because this number is going to be way different than 10 times 7. Right? All right, so we could do this by hand and everything, or we could use calculators, right? So if we get our calculators up here, and I'm going to get a new, let's see if I can get a new page. There we go. All right, so to do this, we're going to need to do 10 to the 7th. So we need to type in our base first, which was 10, right? That's a big number. Then we need to do the exponent, and on calculators, it's going to be the caret button, which just looks like that up arrow. And it's to the left of the 4. Right. The nice thing about the yellow calculators that we have, it'll actually make the number small and put it up there like it looks in the book, right? If you use one of the black calculators we have, they'll actually write this thing. Maybe I can't write on this. There we go. 10 to the 7th, like that, right? So this is a little bit nicer because it looks a little bit better than the other way. So it's going to give us a little All right, and then what was our exponent? 7, that's right. So 7, and then I hit enter. There we go. And it gives us, ooh, that looks like about 10 million. And that's a big number, right? What's 10 times 7? 70. What was 10 to the 7th? Yeah, 10 million. Those are a little bit different, right? They're really close, but they're just a little bit different. All right, so this is going to be 10 million. We'll use red. Right, which is nice. And do you guys know the trick with using powers of 10? Yeah, because the exponent is 7, how many zeros do we have? 7, which makes it easy, right? When we do 0.2 to the 5th power, it's not going to be so easy, right? There's no shortcut ways for that one. So let's go back to the calculator. 0.0032. You know, I trust you, but I'm gonna do it myself just to be sure. All right, so I need to type in my base first, which is 0.2. The to the button. It was the 5th power, right? I don't want to type in a wrong number. And you hit enter, and we get, that's right, 0.00032. So let me write that over here. So we have 0.00032. Now, part A, the answer got really big, right? In part B, the answer got small, right? Why is part B getting small while part A got big? Noah? Yeah, it starts with the decimal point, right? It's smaller than 1, so the answer is going to get really small. 10 is bigger than 1, right? So the answer gets really big. All right, so 1's kind of that divider line. And what's like 1 to the 5th power? What does 1 to the 5th power mean?
1 times 1 times 1.
What's 1 times 1 5 times? 1, okay? So that's why 1 stays the same. A smaller number than 1 will get smaller, and a bigger number than 1 will get bigger. So 1's kind of that line that we need to look out for. One thing here that I'm going to warn you guys about, I'm just going to make a little space over here on my board to talk to you about it, is if I have something like 10 to the 7th power plus 5. Okay? Now we know that 10 to the 7th was 10 million, and if you add 5 to that, we should get 10 million and 5. Okay? So that makes sense, right? But when we do it on the calculator, for as smart as calculators are, sometimes they're really dumb. Okay? So we need to be smarter than the calculator sometimes. So I'm going to try typing it in. Okay? Now I'm going to go. My base was 10 to the 7th power plus 5. Now what did the calculator do?
Add it to the exponent.
Yeah, it added it to the exponent. So this is really going to be 10 to the 12th power, right? That's quite a bit bigger than what we were expecting, right? So you need to be careful with this. And when you have, after you do your exponent, if you're done with exponents, we just hit the right arrow, and then it'll go back down and make us the big ones again. And if you look closely, I mean, sometimes you're in a hurry, you won't notice it, but you know that's still little. Right down here is big. Hit this, now we get the 10 million and 5 we were expecting. Okay, so that's just one thing you need to be careful of. All right. All right, orders of operations. Like you guys said, you've heard of it. These are the rules to solve equations and expressions properly. Okay. The way I talk about them is with PEMDAS. Okay, PEMDAS. PEMDAS, each letter represents an operation, and it is spelled in the way that we do them. So let's start with the P in PEMDAS. Does anybody have a clue what that means? No, I already called on you. Let's go with Takeda. Parentheses, right? Parentheses, right? And how do you spell parentheses? P-A-R-A period, right? Parentheses, there we go. Parentheses. And what do parentheses look like? Show me with your hands. Okay, like this. Can parentheses look like anything else?
Yes.
Like what? The square things, right? Those are called brackets. Okay? And there's actually one more that's kind of a hidden one. That one? The wiggly one? You're talking about like this one? Something like that. This one is used to group numbers together. It's not so much a parenthesis, but it's close. You know, it's on the keyboard in its center place. Right? Straight lines? Good. The straight lines, what do the straight lines mean? Absolute value. And there's one last one that's kind of a hidden one, right? And you don't actually write any parentheses or anything like that, but it's a fraction bar. Right? If I have a fraction of 2 plus 3 over 5 plus 4, there's actually hidden grouping symbols on top and bottom, right? Because to solve that problem, you guys would have added the top and then added the bottom before you divided, right? Yeah, so there's actually kind of hidden grouping symbols in there. All right, what does E stand for? Exponents, right? You spell exponents EXP period, right? All right. Exponents, and those can be on a variable like x to the third, or they could be on a number like, let's say, 5 squared. Right? Exponents. What does the MD stand for? Multiplication division. So multiplication and division. Now, does anybody know why I put them together here while I put these letters by themselves? Yeah, they're almost the same thing, right? Like they're kind of backwards of each other, but they're like kind of the same thing, which means that multiplication and division have the same strength, which means if there's more than one multiplication or division in your expression, we're going to do them from left to right, like we read. Okay, so left to right. So you'll look at the left-hand side, and you'll do your first multiplication or divisions over there, and you'll work to the right. And then the A and the S? Adding and subtracting. All together, that makes PEMDAS. Right? PEMDAS. So let's practice a couple with PEMDAS. Here we go. Oh, and this one, it's kind of got a different fraction sign, but I'm going to write it as 6 minus 2 cubed over 2, right? I like it like that better. Huh? Okay. All right, so we have this. According to PEMDAS, what's the first thing I'm going to do? Parentheses, and I do have some parentheses in there, so I need to do those first. So I have 6 minus 2 is 4, and I have the cube still, and then on the bottom I have 2. After parentheses are gone, what do we do next? Exponents, and we do have one here. We have 4 to the third power, which is 12 is 4 times 3. More than 32.
16 times 4.
64, right? Because we're going to have 4 times 4 is 16. 16 times another 4 is 64. Then what's after exponents? Yeah, we have some division here. So we have 64 divided by 2 is 32. All right. All right, any questions on this one? All right, let's try another. All right. And if we look at this problem compared to the one we just did, okay, is this one evaluating or simplifying? Is this one evaluating or simplifying? Evaluating. What's the key difference? Let's go, Hunter.
Because you have to take out a variable.
Yeah, we're substituting numbers in for variables. So let's do that now. Take out an x and we put in a 5, and then we have squared plus 5 more minus 12 divided by y is 2 squared. All right. Let's do PEMDAS. Are there any parentheses? No. Any exponents? No. I got 2 sets of exponents. Which one am I going to do first? Left one, so we do it like we read from left to right. So 5 squared is 25. I'm going to drop down everything I'm not using exponents on. And then we have 4. Okay. From after exponents, we have what? Yeah, we have a division symbol here. So I'm going to drop down everything I'm not using again. Plus 5 minus, wait, almost went too far for it. Okay, then we have 12 divided by 4 is 3. There we go. I was actually supposed to do the division. Then after division, we have what? Adding and subtracting. I have one of each here. Which one am I going to do first? The adding one. Why am I going to do the adding one first? It's on the left, right? We go left to right. Okay? So we have 25 plus 5. 30 minus 3? 27. Okay? So 27 is our answer. Any questions so far? All right. So the order of operations are basically what we're going to be doing. Looking on page 13, we have 9 through 35 all, then 36 through 55, and 61 through 79 all. All right. All right. Have fun.